in lecture number 2 of Engineering Mathematics 2 MTL 1026. In this lecture, we will going to discuss what are the different method to solving the first order, first degree ordinary differential equation. Okay. So methods of solving first order, first degree ordinary differential equation. Okay. The first method is variable separable. Variable separable. What is variable separable? Suppose a differential equation, first order, first degree differential equation, if first order and first degree differential equation, first degree differential equation can be written in the form, gy dy equal to f of x dx plus constant of integration. Okay. Then the differential equation can be solved by this method, separation of variable or variable separable method. Okay. Let us see some examples. Let us consider these two examples. Dy by dx is equal to sin x plus x cos x divided by y 2 log y plus 1. See, this is very simple example, and obviously it is variable separable. Why? Since with dy we can write the functions of y. Okay. See, gy dy plus fx dx is equal to constant. Okay. Then such type of differential equation is known as solvable by the separation of variable. Okay. So consider dy by dx equal to sin x cos x divided by y log y. This differential equation can be rewritten as 2y log y plus y dy equal to sin x cos x dx plus constant of integration, and integrate. After integrating it, you can add constant of integration. Whenever you apply integral, you add constant of integration. Okay. So 2y log y dy equal to sin x plus x cos x. Sin x cos x dx plus constant of integration. Okay. Now solve it by integrating by parts. So first function and second function. Okay. Similarly, integrating by parts. So after applying integrating by parts, suppose y dy, y log y dy. Okay. So first function, integral of second, which we assume first function or second function, apply Euler method. Now log y first function, this is second function. So log y and integral of y square by 2 minus derivative of first, derivative of y, log y 1 by y, integral of second y square by 2 and dy. Okay. So log y into y square by 2 minus 1 by 2 and integral of y, that is y square by 2. Okay. So this thing. Okay. Plus integral of y square by 2, and similarly sin x and x cos x integrating. Okay. Constant of integration is here. After simplifying, you got it. Okay. You know how to integrate these equations. Okay. Next one, let us consider log of dy by dx is equal to ax plus by. In this form, variable separable is not applicable. So what we can do? Take exponential both sides. Now dy by dx is equal to e to the power ax plus by. And this can be written as dy by dx equal to e to the power ax into e to the power by. Now variable is separable. Dy e to the power by e to the power ax dx. Okay. Now integrate it, add constant of integration and solve it. You find the solution of differential equation. Okay. Now come to the second. Find the solution of this equation. Okay. So rearrange the term. Rearrange the term. Rearranging the term y 1 minus ay equal to a plus x dy by dx. So this can be written as dx by a plus x and dy by y 1 minus ay. Okay. So for integrating plus constant of integration. So for integrating, change this 1 upon y 1 minus ay into partial fraction. Change into partial fraction and integrate it. Okay. So partial fraction is this one. Now integrate it. So this one is the integral. Okay. Now second example. Second example after rewriting and rearranging the term 1 plus x square plus y square plus x by dx. Okay. So this differential equation can be written as square root of 1 plus x square into square root of 1 plus y square equal to minus xy dy by dx. Okay. So this can be written as 1 plus x square dx divided by x equal to y dy 1 plus y square. Okay. This 1 plus x square, this one, this we can rearrange as or rationalize it 1 plus x square divided by x into square root of 1 plus x square dx plus second term is okay equal to now right hand side is okay, no problem. Let us consider 1 plus y square is equal to z square something, so it is easily integrable. Okay. So this one can be written as 1 upon x 1 plus x square plus x square x divided by 1 plus x square. This one is cancelled out. Okay. Now 1 plus x square can be assumed as t square and solve it. So this one is also integrable, and in this term you can assume x is equal to 1 by t. Let us see. In this term x is equal to 1 by t and solve it, right? This one is integrable and integral is this. Similarly, this is integrable, integral is this, and this one is integrable, integral is this. After applying the transformation 1 plus x square or u square and 1 plus y square is u square. Okay. So y dy is equal to u du. Okay. So u du divided by 1 plus y square, that is u. So this is du means u. What is u? 1 plus y square whole to the power 1 by 2. This one. Okay. Similarly, this thing 1 plus x square whole to the power 1 by 2. Okay. So all three are integrable, hence we find the solution of. Now come to the second topic. What is homogeneous differential equation? If we are talking about first order and first degree. Okay. A first order first degree differential equation is said to be homogeneous if it can be written in the form of dy by dx is equal to function of x by y. If y is dependent and x is independent, or if x is dependent and y is independent, then this can be written as, okay, this is function of y by x. This is function of y by x. dy by dx is equal to function of y by x, or dx by dy is equal to function of x by y. So any differential equation of first order first degree which can be written in this form is known as homogeneous. Okay, homogeneous differential. Or simply in our language we can say check the power of dependent and independent variable. If the power of dependent and independent variable in each term are same, then such differential equation is homogeneous. Suppose what is this? 3. X power 1 v power 2. That is 3. This is 3. This one is 3. Okay. So this differential equation is homogeneous. This is homogeneous. Now next problem is that after verifying that differential equation is homogeneous, how to find the solution of the differential equation? Okay. How to find the solution of the differential equation? Okay. Once you verify the differential equation is homogeneous, you can apply the transformation. What is transformation? Let v is equal to y by x. When v is equal to y by x means what? Y is equal to x into v. So dy by dx is equal to v plus x dv by dx. Now after this transformation, this becomes v plus x dv by dx is equal to function of v. Function of y by x is v. And this can be written as x dv by dx is equal to f of v minus v. And this can be written as dv f of v minus v is equal to dx by x. Okay. So this thing is variable separable. Right? Here maybe this differential equation is not variable separable. But after transformation, y by x is equal to v. And differential equation become variable separable. Now integrate it and you find the solution. Replace v by y by x. Okay. So come to the solution of this is homogeneous. No problem. This differential equation is homogeneous. Okay. So dy by dx can be written as in this form, and this is function of y by x. So this differential equation is homogeneous. Now how to solve this differential equation? Apply v is equal to y by x, y equal to xv, and dy by dx equal to y by x is equal to v, dy by dx equal to v. So v plus x dy by dx equal to minus plus 3v square v cube plus 3v. Now this minus v. Okay, and this is equal to 1 minus v square minus v to the power 4 minus v square. Okay, and this thing v to the power 3. Okay, so this becomes minus 1 minus 6v square v to the power 4. Okay, divided by v cube plus 3v. Yes, yes. Okay, so this one dx by x, sorry, x dv by dx equal to minus 1 minus 6v square v to the power 4 divided by this one. This become plus v cube plus 3v, right? And this can be written as v cube plus 3v dv divided by v to the power 4 6v square plus 1, okay, equal to dx by x. Okay, now multiply 4 here and 4 here. Okay, so this become 4v cube 12v and v to the power 4, this one is 6v square. Okay, 6v square plus 1 dv. And after assuming this is t, This one is t. So 4b cube 12b dv is dt. This becomes d by t with negative sign. So minus log t, minus log, and t before 6b plus 1. And now changing v by x. You got this. Okay. You can easily verify it. This is the solution of differential equation, homogeneous differential equation. Okay. Consider the second one. Dy by dx is equal to y by x tan y by x. Again, assuming that y by x is equal to v or y is equal to xp. So dy by dx is equal to v plus x dv by dx. Right? Replace this dy by dx by this thing. V plus x dv by dx. This y by x is v. This one is tan. So v and v are cancelled out. Now this is very simple. This thing can be written as dx by x, and this one is dv by tan v. Okay, and simplify it. Replace v by y by x. Okay, we got this solution. This is the answer. Okay. Okay. In next lecture, we will discuss about how to convert a differential equation into the homogeneous.